reaction which is exhibited by benzene ring system. Bromination is one example. As we know, halogens are chlorine, bromine, fluorine, iodine. Bromination occurs and chlorination occurs partially. Bromination, we take it as an example. Bromine reacts with benzene in the presence of an Lewis acidic catalyst like FeBr3 or AlCl3 or zinc chloride and so on and so forth, to give rise to corresponding bromobenzene along with the byproduct HBr. This reaction is called as bromination of benzene. The bromination occurs in the similar steps as that of the another electrophilic substitution reaction. In any electrophilic substitution reaction, the first step is the formation of an electrophile. The FeBr3 which we use, the Lewis acid catalyst, is a catalyst which catalyzes the process. If you look into the mechanism, the bromine, this has the lone pair of electrons, it reacts with FeBr3. This Fe is positive center because it is flanked between all electronegative atoms bromine. This is electron rich bromine and pyrrole is electron deficient. As unlike poles attract each other, the reaction occurs to give rise to a complex formation. These electrons are shared with iron. That's why iron has got electrons, it has become electron rich. This is not the electrons, as it has shared its electrons with iron, it has become electron deficient species, which we represent it as plus. This is the first step and is the rate limiting step. The formed complex, it reacts with benzene. The positive center is here. To satisfy this positive center, the electrons move towards to the bromine, rendering this bromine positive. Here, the electrons move towards one end in the presence of Br plus electromeric effect. The pi electrons attacks on this bromine. It gives rise to a bromobenzene in which the adjacent carbon has a positive center. To satisfy this positive center, these electrons move, creating another positive center in the adjacent carbon. The pi electrons on the adjacent carbon again moves towards this positive center to satisfy its positivity. It is giving rise to a new positive center. It is something like when my friend or my neighbor is in trouble or is in need, I will try to help him. When I help him, I will become electron deficient. Right. It is something like a middle class fellow where he gives something, whatever he has to his friend, he will become deficient. To satisfy this positive center, the carbon-hydrogen bond breaks and the electrons between this carbon is utilized to satisfy the positive center, and it gives rise to bromobenzene with the liberation of hydrogen as a proton. This is the second step in the reaction. The H plus which is formed is unstable. FeBr4 minus which is formed, it is also unstable. That's why H plus reacts with FeBr4 minus. This is in excess electrons, this is in need of electrons. Thus the excess electrons it transfers to H plus through bromine and it forms HBr and it gives rise to FeBr3 backside. The FeBr3 that we have used as a catalyst, we have recovered back that catalyst. Catalyst is like our teacher who makes us to write examination but he won't write the examination. That's why your catalyst is like your teacher. This is all about the bromination of benzene. Thank you.